Hello everyone, very good evening. Kindly confirm if audio video is clear. Good evening everyone. Please confirm if audio video is clear. Good evening Ashwini. Okay, so let's begin with the eighth lecture of this series on database management system. We are discussing a structured query language. So in the last class, we have understood that how exactly a correlated subquery is executed. We have understood the order of execution, and we have also understood the concept of as a clause for renaming the relation or attribute, and we have also understood the concept of with clause, using which a subquery can the output of a subquery can be given a new name, and that name can be referred by other subquery or main query, right? So, and we have also seen the examples for same. So that's what we have discussed in the last class. So today we are going to cover some more questions, some more gate previous year questions on the concept of SQL, right? So this is your very first question. Let's look at this. The question is very lengthy. So some questions may require more than one slide. So please try to understand. This is your SQL query. This is your SQL query. Select scheme name, comma, count as straight from school, comma, enrollment, comma, exam result tables where these conditions are true. Where these conditions are true. Now, apart from that, so these conditions must be true, and whatever the school ID in the table is, it must be in. So this condition should also be true. Clear? Getting the idea. So, sir, along with all these four conditions, this in should also return true. Okay, so these are the relations which are given in the question. So, student is one table. Please try to understand. Please try to understand. You guys may think that this information is not important, but this is a common data question. One part of this question is actually a structured query language. Another part is a tuple relational calculus query that we will discuss at the later point of time in the discussion. But we will have to analyze that what exactly is present in these relations in order to provide the solution of that tuple relational calculus query. But with respect to SQL query, it is the easiest question. हाँ बिल्कुल स्टार्ट होगा कौशिक जी 27th से from 4 to 6 p.m. we are starting discrete mathematics. Don't worry about that. है ना? चलिए. So that's the idea that these are four relations. If you look at this query and then you look at the options which are given, right? Then this query, if you try to solve this particular query, may take 3-4 minutes of your time. But if you first look at the options which are given in this question, one is for each school with more than 200 students appearing in the exam, the name of school and the number of hundreds scored by its student for each school with more than 200 students in it. So one says more than 200 students appearing in the exam. Another says more than 200 students in the school, and the name of the school and the number of hundreds scored by its student. For each school with more than 200 students, again the number of students are more than 200 in school, and the name of school and the name of school and the number of its student, and the number of its student is scoring hundreds in at least one exam. Whatever. The fourth option is nothing. The query has a syntax error. Nothing. The query has a syntax error. Please try to understand. This is your query. This is your query. What do you know, sir? Whatever is present here is the where condition. Whatever is present here is the where condition. And there is a group by clause. There is a group by clause. Please try to understand. What did I say? In the select command, if you select any other attribute, along with an aggregate function, if you select any attribute in the select clause along with aggregate function, then that attribute must be present in group by clause. Then that attribute must be present in group by clause. Here, the attribute that is present in the select clause along with aggregate function is school name, whereas the group by clause is applied on school ID. Group by clause is applied on school ID. So this query is an invalid query. It will not execute. Got the idea? So if you know this basic concept, you will not have to worry that what exactly is being produced by this particular SQL query, because the only context is that if something is present in the select clause along with aggregate function, then that attribute must be present in the group by clause. But because it is not present in the group by clause, therefore this is an invalid query and nothing, because the query has a syntax error. This is not the correct syntax for an SQL query, for a SQL query. Got the idea? So if you focus on the right thing, then a question which otherwise may seem lengthy will be just a piece of cake. Got the idea? So if you just focus on this simple concept, not more than 30 seconds or 45 seconds are required to provide the answer of this question. Otherwise, you will do many things, and ultimately, if you do not realize this, you will end up giving one of these three answers, and that will be an invalid answer. The problem is, if you do not know the syntax, then you will not give the answer as D, but you will try to execute that query, and you will find out that the output that is being produced is similar to one of these three. So ultimately, you will waste 3-4 minutes of your time, and then you will score some negative marks. Got the idea? Anyway, so that is just one question. Let's move to the second question. Let's move on to the second question. The employee information in a company is stored in the relation employee. So you have an employee table in which the name of the employee is the primary key. Names will be unique. That's what I understand. Sex of that particular employee, salary of that particular employee, and the name of the department for which that particular employee works. Then we have consider the following SQL query. Consider the following SQL query. Select something from employee, okay, where sex will be equals to male. Now, what will happen? So, what will be the order of execution? So, first, you will take the table employee, then you will apply this where condition. That means the tuples with the male employee will be selected. But is it really the order? Let's try to understand. Then we'll have whatever is selected by group by clause, we will whatever is selected by where clause, we'll group them based on the department name. And then we'll see that the names of those departments for which having condition is true will be selected. But the moment you go and see the having condition, you will say having average salary of the department greater than something. Oh, this something is a subquery. So at position 0, let's try to understand what type of subquery is this. This is a correlated subquery, or this is an independent subquery. Sir, we just want to select the average of salary from the employee table. We don't need any tuple from the outer relation. We'll simply calculate the average of the salaries in the employee table. So this will give me the average salary in the company. Why? Because this average is not calculated with respect to males or females. This average is calculated on the complete employee table. So it will give me the average salary of the company. Gives average salary of the company. What type of query is this, sir? It is an independent subquery. So forget about everything else. The very first thing that will be executed is this independent subquery. So At number 0, I would rather say start counting from 0 rather than counting from 0. First of all, this particular subquery will be executed and the result of this subquery will be available. Result of this subquery will be available. Then you will select the tuples from the employee table. You will check whether the where condition is true or false. So you will for all the tuples of the employee table, you will check whether the where condition is true or false. Now, once you have the output with respect to where condition, you will have the tuples in which you will have the tuples which are with respect to male employee. You will have the tuples with respect which are with respect to male employee. Then you will group those tuples based on the department name. Then you will group those tuples based on the department name. And then finally, you will check this having condition that with respect to a department, the average salary. So this average salary will be calculated for what? So this average salary will be calculated for the male employees. This average salary of male employees. Male employee in our department. If average salary of the male employee in our department is greater than the average salary of the company, then having condition will be true for that department. Then having condition will be true for that particular group of department, and that particular department name will be selected. So what will be produced as an output? So the output will be the name of the department for which the average salary of the male employee is greater than the average salary of the company. Greater than the average salary of the company. So it returns the name of the department. The query is, it returns the names of the departments in which the average salary is more than the average salary in the company. Sir, the department in which average salary? No, average salary of more male employee. The average salary of male employee is more than the average salary of all male. Sir, here we did not apply the condition of male. Here we did not apply the condition for male. Therefore, this all male will be false. No. So, the average salary of a male employee is more than the average salary of employee in the same department. From where this concept of same department came into the picture? We have calculated the average salary of the company. The last one will be the average salary of male employee is more than the average salary in the company, complete company. Therefore, the correct answer will be D. How easy it is? But you just need to understand the order. You will be confident enough that what exactly will be produced by an SQL query. You just need to understand at every step what exactly is being produced by the different statements. Clear? So that's again an interesting question. Okay. So generally students who are not comfortable with the SQL query will generally think that the answer will either be B or C. They will think in terms of B or C because they see this department name somewhere being evaluated and the male as a where clause. So they might think that B or C will be the correct answer. But the thing is, average salary of male employee is more than, so this is the average salary will be calculated for male employee in our department. So for whichever department, the average salary of male employee is more than the average salary of all the employees in the company that will be selected. Okay, so that's a very old question, but a good question. So let us discuss this as well. What happens here? So the relation, what is the relation? The relation book is one relation which has two attributes, title and price. Okay, so let's say if I create a table with the name book, which has two attributes, title and the price. Just to explain the concept, I'm considering this. Okay, sir. Contains the titles and price of different books. Yeah. Assuming though that no two books have the same price. assuming that no two books have same price. It is guaranteed that price will be different. So let's assume that the prices are $10, $20, $30, $40, $50, $60, $70, whatsoever. Right. So average salary, prices, salary to gayi. So prices for all the books are different. Now, what does the following SQL query list? What does the following SQL query list? So the first idea is, sir, we are selecting titles. We are selecting titles. So if at all it is the case, that two books are of same title, it may be the case that the title of the book is, it didn't say anything that the title of the book cannot be same. Nothing is specified that whether the title of the book can be same or not. So title of books may be same. Don't know, right? But from the question, it is not clear whether the title of the book can be same or not. So even if the title of the book is same, then also the final answer will not change because we did not use the keyword distinct. If we use the keyword distinct, then this query will be wrong. This query will be wrong because same title will be produced more than once. Same title will be produced more than once if it satisfies the given condition. Okay. Now what, sir? We will select the title. We will select the title C, D, E. Yeah. We'll select the title from the book, from the table book, and we have renamed this first instance of book as B. So let's call it, there is another instance of book which is B. Now what will happen? So it will select something, count asterisk, again from book ST. This time this book will be renamed as a T. So we'll have two instances of the same book. One is treated as B, which is with respect to outer query, and another is ST, which is with respect to inner query. So A, B, E, E, B, B, 10, 20, 30, 40, 50, 60, 70. Fine. Okay. Now what will happen? Sir, the book or the tuple from this table B, the tuple from this table B will be selected. The tuple from this table B will be selected if this where condition is true. Now what is the concept of where condition? Sir, in where condition, we will first execute this subquery. And this is what type of subquery is this? So this is a correlated subquery. This is a correlated subquery. Why exactly it is a correlated subquery? That is a correlated subquery because for comparison, it uses the attribute price of the outer relation B. It uses the attribute price of outer relation B. So because the inner query uses the attribute specified in the outer relation, therefore this query is a correlated query. Now, how exactly the selection will take place? So please try to understand. You will take the first tuple from the book B and you will go to the first tuple of book T, instance T of the book. So now, sir, please check whether the price in the inner book table is greater than the price of the tuple under consideration or not. So, sir, here the price is not greater, therefore it will not get selected. But with respect to all other tuples, what will happen? So with respect to all other tuples, the price with respect to tuple of table T will be more than the price of the tuple with respect to alias B of the book table. Therefore, for all other tuples, they will get selected. Now, what's the idea? Sir, when this is the selection, so the 6 tuples are selected. So the count with respect to the selected tuples will be 6. So 6 is less than 5 or not? No, sir, 6 is not less than 5. 6 is not less than 5. So because 6 is not less than 5, therefore this less than will return false. This less than will return false to this where clause. The less than will return false to this where clause, and because this less than returns false, that means the where condition is false. So for the first tuple of the book table, where condition is false. For the first tuple of the book table, where condition is false. Now you just need to understand one simple thing, that whichever tuple is under consideration, from this alias B of the book table, if there are 5 or more books in the book table whose prices are more than or equal to the prices, or more than or equal to the price of the book corresponding to the tuple of alias B of the book table, then for that particular tuple, this less than 5 condition will be false. This less than 5 condition will be false. So if there are 5 books, all the prices are different. That's for sure. All the prices are different. So if there are 5 tuples, let's look at this. So if I say 20, so there are 6 books whose prices are more than the price of the book A. Similarly, with respect to 20, this will be false, but still there are 5 books. There are 5 books. 1, 2, 3, 4, 5. So with respect to 20, there are 5 books with respect to which the condition, or 5 books in the book table such that their prices are more than the book with respect to second tuple. Therefore, again, this will not be less than 5. So the idea is, the moment you go for the book number C, so you know that this is the 5th most expensive book. So this is the first most expensive book, this is the second most expensive book, this is the third most expensive book, this is the fourth most expensive book, this is the 5th most expensive book. So the moment you go to this tuple corresponding to book C, what will happen? So this will be false, and this will also be false. So this time there will be only 4 tuples in which the prices are more than the price of book name C, book with title C. Therefore, this time the count will return only 4. So when you are comparing for the 5th most expensive book, the count will return 4. When you are counting with respect to 4th most expensive book, the count will return 3. When you are counting with respect to 3rd most expensive book, the count will return true, etc. So let's try to understand what will happen. So with respect to book C, the count will return 4. This count asterisk will return 4 because only 4 tuples. Because only for 4 tuples this where condition is true. Therefore, count will count those 4 tuples, and the result will be 4. 4 is less than 5. Yes. 4 is less than 5. So for the 5th most expensive book, the where condition will be true and 5th most expensive book will be selected. Similarly, the 4th most expensive book will be selected because with respect to 4th most expensive book, the count will return value 3. And similarly, this with respect to this most expensive book, the count will return 0. The count will return 0 because no tuple will be selected such that the price is more than the most expensive book. Such that the price is more than most expensive book. If there is an equality condition, then answer will differ. If there is equality condition, then answer will differ. So what exactly will be selected by this outer query? Sir, outer query will select the tuples with respect to 5 most expensive books, and out of those tuples the title will be selected. So basically we will output the titles of 5 most expensive book in the book table. We will output the title of 5 most expensive book in the table. So title of the 4 most expensive book, no. Title of the 5th, not only 5th, all 5, no. Title of 5th most expensive book, title of 5 most expensive books, right? So the correct answer will be D. Again, the concept of correlated subquery. For each tuple in our query, the complete inner query will be executed on the complete inner relation, and based on that you will decide whether the tuple from the outer relation should be selected or not. Simple concept. So again, if we say equal, if we apply the equality condition, then what will happen? If there is an equality condition, then the output will contain the title of 6 most expensive books. The output will contain the title of 6 most expensive book, because of this equality condition, when you are comparing with respect to 6 most expensive book, then also the condition will be less than equals to 5 will be true. Clear? Because the price of that book will also be equals to itself. That's it. So this is a simple question, but you just need to understand that how exactly this correlated subquery will execute. Again, one more question. Look at this. Consider the table employee. So you have a table employee which has attributes employee ID, name of the employee, department of the employee, and the salary of that employee. Then what? And the two queries Q1 and Q2 as given below. Two queries. This is your query Q1. This is your query Q2. So these two queries are given. What else is given in the question? Assuming that department 5 has more than one employee. So it is given that department 5 has more than one employee. That means it is not possible. That means it is not possible that there is no employee in the department number 5. What will happen if there is no employee in the department number 5? I'll explain that what will happen if department number is not equals, there is no employee in the department 5. So please, if there is, I'll explain with the query. Now, assuming that department 5 has more than one employee, it is guaranteed that there will be more than one employee, not only one, there will be more than one. At least 2 employees are there. So when I say more than one employee, that means at least 2. At least 2. Now what is given? We want to find, what do we want to find? Sir, we want to find the employees who get higher salary. We want to find the employees who get higher salary than anyone in the department 5. Come on, that's the basic difference. This is anyone means everyone. Anyone will be at least one. Anyone more salary than anyone in the department 5. Anyone means everyone. Got the idea? So we are actually looking for the employees who get higher salary than all the employees of department 5. Not at least one employee of department 5, but all the employees of department 5. So we are looking for the employees who get higher salary than all the employees of department 5. Which one of these statement is true? Which among this, these are the 4 things. Which one of these statement is true for any arbitrary employee table? So we actually want to find the employees who get higher salary than all the employees of the department 5. So let me first explain the query number 2. Let me first explain the query number 2. What will happen? Sir, employee table, one is the instance or one is the alias E of the employee table. Another is the alias S of the employee table. So there are 2 alias. If you look at this subquery with respect to query Q2, if you look at this subquery with respect to query Q2, then it select the distinct salary. It select the distinct salary from the employee table S where the department of the tuple of table S is equals to 5. Does it use any attribute specified in the outer relation E? No, sir. So this is an independent subquery. This is independent subquery. What exactly will be the output of this independent subquery? Sir, it will produce all the distinct salaries from department 5. So it will produce a set output will be a list of distinct salaries with respect to department number 5. So we have a list of we have the list of all the salaries with respect to employee of department 5. Then this outer query will execute. So first inner query will execute, that is we'll create a list which contain the distinct salaries from the department 5. Then you will take this first tuple from the employee table and you will check whether the salary of the employee in the selected tuple is greater than any of the value in this list or not. So the idea is, if the salary of the employee under consideration is greater than the salary of any of the employee in the any of the employee of department 5, then for that particular employee this where condition will be true and the employee ID of that particular employee will be selected. So what's the difference? Sir, if you look at query number 2, then in this, with respect to the query Q2, will produce the EIDs of the employee whose salary is more than at least one employee of department 5, whose salary is more than at least one employee of department 5. Yeah. If you use, please, if you use greater than all, then what will happen? So this greater than all will return true if and only if the salary of the employee is greater than all the different salaries of the employees of department 5. So in that specific case, it may be true. Getting the idea? So you should not use greater than any. You should actually use greater than all. But what's the problem with greater than all? What is the problem with greater than all? So the moment we say that employee table will contain at least one employee or will has more than one employee, that means the inner query can never be empty. Inner query output will never be empty because there will be at least one employee, and as long as there is any employee in the department 5, the output of this query will not be distinct. But the problem is what? Sorry, they didn't say that the salary cannot be null. If the salary happens to be null, then ultimately this will be an empty relation, and based on that, this will be problem. But anyway, we are not considering with respect to null value. So rather than greater than any, if you use greater than all, then it will select the tuples from the employee table whose salary is more than all the salaries with respect to department 5. So greater than any will be wrong because it will give the employee ID. If it will produce the employee ID if the salary of that employee is more than any one of the employee, or if his salary is more than at least one employee of department 5. But we are looking for all the salaries. So Q2 is definitely wrong. So it says that Q1 is the correct query. We don't know. Q2 is the correct query. B is definitely wrong. B is definitely wrong. Both Q1 and Q2 produce the same answer? No. I don't know that both Q1 and Q2 will produce the same answer or not, but Q2 is definitely wrong. Q2 is definitely wrong. Now let's think about this query Q1. Sir, what type of query is this? What type of query is this? So this query is independent subquery, but here we have an alias E of employee table, and this is your subquery. This is your subquery. We are comparing that the salary in the tuple of inner relation must be greater than or equal to the salary in the tuple with respect to outer relation. So because we are using an attribute which is defined in the outer relation, therefore it is a correlated subquery. What is this? It is a correlated subquery. So it will execute tuple by tuple. It will execute tuple by tuple. Okay. Let me explain the concept. So let's have some tuples in the employee table so that you will be able to visualize it. Let's say that this is your employee table, and let's call it E. There will be another employee table that we'll call it S. Yeah. So employee table. Forget about other things. We need to focus only on three different aspects. One will be EID that will get selected. One is the department number. Department ID is being used or department number. It's okay. Department. So let me use in the short form. And a salary. And a salary. So let's say that we have employee E1, E2, E3, E4, E5, E6. At least two employee, let's say assume that E4 is from department 5, E6 is also from department 5, 400 is the salary with respect to employee E4, 700 is the salary with respect to employee E6, E1 works for department 1, and the salary of the employee is, let's say assume 600, E2 works for department 2, the salary is a 700, E3 works for department 3, the salary is, let's assume 800, E5 works for department 3, and the salary is, let's assume 400. The salary is, let's assume 400. So why these two values are equal? We want to check whether the tuple with respect to equality condition will also get selected or not, right? So that's what we want to compare. So these are two instances, or these are two alias of employee table. One is E. So this alias E is with respect to outer relation. Alias S is with respect to inner relation. Now what will happen? Sir, we can understand this particular query will execute tuple by tuple with respect to tuple of outer relation. So you will take first tuple of the outer relation, and then what will happen? With the first tuple of the outer table, you will go to the first tuple of the inner table. Now you will check that the very first condition is that the department with respect to S must be equals to 5. That means we are trying to compare with the salaries of department 5. We are trying to compare with the salaries of department 5. So this tuple will not get selected. This tuple will not get selected. Let me explain. This will not get selected. This will not get selected. No, no, no. Now this for this fourth tuple, the department is equals to 5. So first condition is true. Now the second condition is that whatever is the salary in the inner relation, whatever is the salary in the inner relation must be, that means salary in the inner relation. Sir, when exactly you will check for this particular condition? You will check for this condition when the department is 5. When the department is 5, that means you are checking whether the salary of the employee with respect to department 5, salary of the employee S is the tuple from the inner relation. So salary of the employee with department 5 is greater than or equal to to the salary of the employee corresponding to outer table or not. So that's the idea. Come on, let's look at this. So here the salary of the employee is 400, and this 400 is not more than the salary of the employee E1. Therefore, this is also not selected. This is also not selected. Let's look at this. Now, this E4 is obviously not selected. What will happen with respect to E5? Sir, the department is not 5, so forget about that. So here, the department is 5. So, this time, the salary of the employee of department 5, the salary of the employee of department 5 is greater than the salary of the employee from the outer relation, is greater than the salary of the employee from outer relation. Therefore, this will get selected. Now, if something gets selected by this inner query, then exists will return true, but not exists will return false. So please try to understand. If there is any employee of department 5, whose salary is more than the salary of the employee of the tuple under consideration, then inner query result will not be empty. In that case, not exists will return false, and that particular employee will not get selected. So if there is any employee in the department 5 whose salary is more than the salary of the corresponding employee, then that particular employee will not be selected by the outer query. Clear? Now, that's with respect to first tuple. Let's see what happens with respect to second tuple. Let me explain with respect to second tuple, and then you will understand the concept. So this is the second tuple. So it will go here. So obviously, department is not 5. Department is not 5. Department is not 5. Here the department is 5, but the salary in the tuple is not greater than or equal to the salary of the employee. Here department is not 5. Here what will happen? So 700 is greater than or equals to 700. Therefore, again this tuple will be selected. So even if the salary of the employee, is equal to the maximum salary of department 5, then also the inner query result will be non-empty for the tuple. That means exist will return true and not exist will return false. Therefore, the corresponding employee will not get selected. But what if the salary of the employee is more than the salaries of all the employees of department 5? So that is with respect to this third tuple. Sir, department is not 5. Department is not 5. Department is not 5. Here department is 5, but 400 is not greater than 800. 400 is not greater than 800. Therefore, this is also not selected. Here department is not 5, not selected. Right here. So department is 5. So we'll go for the second condition, but this 700 is not greater than 800. Therefore, this tuple will also not get selected. So with respect to employee whose salary is more than the salaries of all the employees of department 5, the inner query result will be empty. That means exist will return false, but not exist will return true, and the employee ID of the corresponding employee will be selected. So that's the idea. You just need to understand. Once you trace this query, you will realize that we are comparing the salary. We are comparing the salaries of the employees of department 5 with the salary of the employee under consideration. So if any of the employee of department 5 has salary more than or equal to the salary of the employee under consideration, then that particular employee will not get selected. But if there is no employee of department 5, if the department is not 5, then anyway those tuple will not get selected. We don't need to check with respect to employees of other departments. We only need to check with respect to employees of department 5. So if no employee of department 5 has a salary more than the salary of the employee under consideration, then no tuple will be selected by the inner query, and for that particular tuple from the outer relation, not exists will return true, and that particular tuple will get selected. So with respect to this, what will happen? Sir, by this particular query, please try to understand. With respect to this particular query, no employee of department 5 can be selected. Why? Sir, it's but obvious that no employee of department 5 should be selected, because we are saying that find the employees who get higher salary. So the employee of department 5 cannot get higher salary than all the employees of department 5, because his salary will be at least equals to himself. Even if it is the maximum salary, then it will be equal to the salary of an employee of department 5. It is not more than all the salaries of department 5. Therefore, no person of department 5 can ever be selected by the statement given in the question. So that's what will happen because of this particular query. What will happen? Sir, if the employee is of department 5, then the salary of the employee of department 5 will be equal to at least one salary of department 5, and that particular tuple of department 5 will be selected by the inner subquery, and that therefore the output of inner query will not be empty. Therefore, exists will return true, but not exists will return false, and no employee of department 5 can ever be selected because of this first query. Therefore, the first query will do what exactly is required. First query will find the employee who get higher salary than anyone, that is all the employee of department 5. So what will happen? Sir, Q1 is the correct query. Q1 is the correct query. Q2 will be correct query if it is written as greater than all, but here it is written as greater than any. Therefore, Q2 is not the correct query. Both Q1 and Q2 produces the same answer. They will definitely produce different answers. So C is obviously not true. Neither Q1 nor Q2 is the correct query. No, Q1 is the correct query. Therefore, option D is false. Q1 is the correct query. Therefore, option D is also false. Clear? So that will be also, we have discussed some questions that how exactly you will proceed with the structure, with the query given in the question, and how exactly you will try to reach to the solution, that what will be produced by that particular query, right? So with that, we will end this session, and we'll see some more questions on SQL along with relational algebra. So I've discussed two different topics. One is relational algebra, another is SQL. So in the tomorrow session, I'll include the questions which are related to both SQL as well as relational algebra. So the questions have been asked in the GATE exam, which will require the knowledge of both the topics, relational algebra as well as SQL, to give the right answer of that particular question. So I'll include those type of questions in the tomorrow's session. So that will be all. And tomorrow I'll have the last session of structured query or the query languages. Then we'll come up with another series of DBMS in which we'll discuss some other topic of database management system. But I believe that I have discussed all the concept of query languages, both relational algebra as well as SQL in this session. If you want any specific thing, then you can post your comment and you can ask that, sir, this so and so topic is required from the SQL. So I'll try to include that particular topic in the tomorrow's session. Okay. So that's just because tomorrow it will be the last class of query languages. Therefore, if you have any specific requirement for any specific topic, then you can post your comment, and based on that, I'll try to include that particular concept in the tomorrow's session. Okay. So this is it. Thank you very much for joining. Take care. Keep learning.